Today we are learning about quadratic applications. So we are going to see where quadratic functions pop up in regular life. So in problem number 1, it says the length of a rectangular sign is 6 inches more than half its width. The area of this sign is 432 square inches. Write an equation in one variable that could be used to find the number of inches in the dimensions of this sign. Determine the method you would use to solve, but do not solve. Okay, so it looks like we're just setting up an equation. Good to know. Now, with these types of problems, we call them let statements, right? With let statements, you want to start with the last piece, then work backwards. So here they tell us that the length of a rectangular sign is 6 inches more than half its width. So we are going to, let's put length in terms of width. So we have length is equal to 6 plus 1/2 of the sign's width. So the sign's width is just going to be W. So if we have a rectangle over here, we know that this is going to be the length and this is going to be the width. So let's put our dimensions onto the figure. So we have 6 plus 1/2 of the width is the length. Now we know that the area of this sign is 432 square inches. And we know that the area of a rectangle is length times width. So we are going to substitute all the information that they have given us from the problem into our little setup here. So they tell us that the area is 432, so we're going to put 432 where we see the area. We know that the length is this guy right here, so we're going to substitute in that to our formula. We have 6 plus 1/2 times W times the W, which is just W. So now we have an equation in one variable being in terms of W, that we could use, to find the number of inches in the dimensions of the sign. So I would expand out the right-hand side in order to solve and simplify. Then I would solve it using, I don't really know what method is obvious at this point. So let's multiply it out and see what we should do. I'm going to distribute a W to each piece in the parentheses. And now I'm going to move the 432 to be over with the rest of it. And I would get 1/2 W squared plus 6W minus 432 is equal to 0. I don't really like working with this 1/2 right here, so I'm going to multiply the whole side of the equation by 2. And since it's an equation, what I do to one side, I got to do to the other. And that is going to get rid of the fraction for me. So now I have W squared plus 12W minus, what is that going to be, 864? 864 equals 0. Oh, awesome. I can totally factor this. 24 times 36 gives me 864. So I know that this can be factored. So now when it says describe the method that I would use to solve it, I know I'm going to factor. I don't necessarily have to factor because the problem tells me not to solve, but now I know that it is factorable. So let's just erase this part here because they told us not to solve it. But we're going to take our equation, 432 equals 6W plus 1/2 W squared. And that is going to be our equation. So this would be our equation. And we would solve it by factoring. Now in problem number 2, it says a landscaper is creating a rectangular flower bed such that the width is half the length. The area of the flower bed is 34 square feet. Write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. So right away, as soon as you see a problem where they mention a figure, you're going to want to draw that figure. So I have a rectangle. And it says that the width is half the length. So they give us the width in terms of the length. So in our let statement, we're going to let L equal the length. That is not how you spell length. And let the width be 1/2 of the length. So the area of the flower bed is 34 square feet. So I know that this is going to be the length. The width is going to be 1/2 the length. And the area is equal to the length times the width. So now I just substitute. I have my area is 34 square feet. My length is L, and my W is 1/2 L. So now I'm going to multiply through, and I'm going to get 1/2 L squared. I'm going to subtract. Let's see. Oh no, I'm not going to subtract. I'm going to multiply both sides by 2 to clear that fraction out. And I'm going to get 68 equals L squared. So we are going to take the square root of both sides, and I get L equals, oh, the square root of 68 is not a nice number. So we are going to put the square root of 68 into simplest radical form. Simplest radical form, when I'm thinking simplest radical form, I think, what's the largest perfect square that is a factor of 68? So 4 is divisible by 68, so I'm going to do the square root of 4 times the square root of 17. And the square root of 4 is positive or negative 2 times the square root of 17, and that's going to give me my length. So I'm going to say length is equal to negative 2 square root of 17, or length is equal to positive 2 square root of 17. Now, if I'm thinking about a length of a flower bed, a negative number does not make any sense at all, so I'm going to reject that. And the only answer choice that makes sense is the length is equal to 2 times the square root of 17. Now, am I done answering the problem? No. The problem says write and solve an equation to determine the width of the flower bed to the nearest 1/10 of a foot. So the width is what I really want. I have found the length here, but I need to find the width. I have an equation to find the width right up here. It is W equals 1/2 times the length. So I'm going to do W equals 1/2 times the length, and I'm going to substitute in my known value for length, which I just found over there, which is going to be 2 times the square root of 17. 2 divided by 2 is going to give me 1, so the width is just a plain old square root of 17. However, the problem says that I need to round to the nearest 1/10 of a foot. Nearest 1/10 of a foot. So I'm going to go ahead and put the square root of 17 into my calculator to get that measurement. And it's going to be 4.1231 feet. And then it tells me to round to the nearest 1/10 of a foot. So I'm going to get 4.1 feet. So the problem says write and solve an equation and then give the width of the flower bed. So if this were the regents, you really want to make your answer super obvious. So our equation is going to be 34 equals 1/2 times L squared. And our width measurement that we found is, actually, let's write that out. And the width of the flower bed is 4.1 feet. And you want to put a little box around your answer for the regents. That's it.